All right, so I'm going to start class. If you need the code again, I posted it in the chat. All right, so if you haven't done your attendance, make sure that that is done. You do not need your digital notebook for class, but it does have some spots in there where you can put important information. So after class, if you would like to go put any important information, things that you may need to write down in there, but we do not have any key concepts and we do not have any vocab words to put in our notebook. All right, so we are starting on lesson 1.4, explaining force and velocity. So I'm going to stop sharing my screen and make sure that you are on Pear Deck. All right, today we will explain how a force can change an object's motion, and then you're going to be able to conduct an investigation on how the strength of a force changes velocity. All right, so for our first activity, you've got a warm-up, and so we are going to read the Sherman Story comic and then explain the difference between force and velocity. All right, so if you want to go ahead and click on this page, it's gonna take you to a comic, and you're going to read the comic and you are going to finish this sentence. All right, so what would you say? And you're going to respond to Sherman in the text box below the image. I'm going to give you guys about 3 minutes to do so. Make sure you read that and finish this sentence. Once you get done with that, make sure that you click hand in and then come back to our Pear Deck. All right, so if you're back in our Pear Deck, I have a question for you. How would you explain to Sherman that force and velocity are different? So how would you explain that force and velocity are different? So you can either copy and paste what you just put in Amplify, or you can kind of paraphrase it and sum up what you said if it's really long. Okay, so you can either copy and paste or you can paraphrase what you said in Amplify. I want to see some of your responses. All right, so make sure you're back on Pear Deck. All right, I'm going to start looking at some responses. If you aren't responding on Pear Deck, make sure that you are. All right, so force is what made the object move, but velocity is the speed and the direction it's moving. Velocity is speed of an object. Force is the strength or power of that object. Force is not always fast. I wouldn't consider a force to be fast or slow, though. Force is always pulling the object and will eventually slow it down, while velocity is motion in a certain direction, causing the object to move. Okay, I think you got it mixed up just a little bit. So force is something that causes the object to move, and velocity is the result of that force. And force is not always going to slow an object down. A force could make an object start moving. It could make an object speed up or travel in another direction. All right, this person, whoever responded to this one, is on the right track with what we're doing today. Velocity of speed and direction of an object. Force is the push or pull applied to an object to get it moving. Good. Force is a push or pull of something, and velocity is like the speed. It is the speed. But remember, velocity is also the direction, so speed in a particular direction. This is good. So velocity is the speed of an object in a given direction, and force is a motion put on an object to make it go in a direction to get a velocity. So that's kind of talking about our cause and effect relationship between force and velocity. Good. So what we are going to do, we are going to use vocab words from the word bank to explain why a baseball changes direction after being hit by a bat. So I'm hoping you guys are kind of familiar with baseball and pitcher throwing and somebody hitting it, and it's going to go in the opposite direction. And so we're going to review this activity. And once we get to our slide, we're going to type our sentences in the next Pear Duck slide to share with the class. All right, so you guys are going to use what's called word relationships. And we have done a word relationship routine, so you should be a little familiar with it. You're going to use this routine to explain this scene. Okay, so we've got this scene with Mary. So Mary swung her bat at a baseball that was moving toward her. She hit the baseball and it traveled in the opposite direction. All right, so Mary swung her bat at a baseball that was moving toward her. She hit the baseball and it traveled in the opposite direction. All right, these are actually not the words that you're going to use, so I'm going to move on to the next slide because you've got 4 vocab words that you are going to use, and they are velocity, force, cause, and effect. And you should be familiar with these. We've been using them the last few days and last week. All right, so you are going to make 2 sentences using at least 2 of the vocab words. All right, you're going to make at least 2 sentences using at least 2 of the vocab words in those sentences. All right, so using vocab from the word bank, write at least 2 sentences explaining why a baseball changes direction after being hit by a bat. And so you've got your word bank right here, cause, effect, force, and velocity. All right, so go ahead and start responding to that in the Pear Duck. All right, I'm going to look at some of the responses. All right, so when the baseball hit the bat, when the baseball was hit by the bat, it applied force, which caused it to have a high velocity and travel far. All right, so a baseball changes direction because the force from the bat causes the ball to have velocity, which affects it by going in high speeds in a certain direction. All right, so make sure when you're saying this, you're being specific. So right here, the baseball will change direction because a force will be applied, such as a push or pull, when we are talking about a bat or somebody hitting the ball with the bat. We are talking about either a hit or you can call it a push. All right, so make sure you're specific when you're talking about this. And they say the velocity or the speed and direction of the object determines where it will move. When Mary hit the ball, the force of her swing caused the ball, I guess you're saying, to move.
Yeah, pretty much.
Okay. All right, so this one is going in the right direction. So the pitcher throws the ball, it goes toward the batter, but when the batter uses force to hit the baseball, it caused the ball to use velocity and shoot off the bat as an effect. Okay, so when we are talking about the baseball coming at Mary, Mary's going to hit it, and is it going to go in the opposite direction or in the same direction that it's been going? All right, so think about that. It does shoot off the bat as an effect, but make sure you're using those vocab words and you're talking about the strength of the force. Okay, so this one is good. The baseball changes direction after being hit by a bat because the force of the bat caused the baseball's velocity and direction to change. All right, so we are going to move on. All right, so your sentences have explained how force and velocity have this kind of cause and effect relationship. And so that's what I kind of talked about before we even started this activity. All right, so the force of the bat hitting the baseball caused the ball to change direction in some sort. It may not have gone straight up the middle, but it did change direction. All right, so when a force is exerted in the direction opposite to an object's motion, the force can cause the object to either slow down, stop moving, or move in the opposite direction. All right, I'm going to post the Pear Deck just in case people don't have it in the chat. All right, so when you guys answered on the 1.5 homework, if you were here on Friday, you would have seen this. We did the 1.5 homework, not 1.5, sorry, the 1.3 homework on Friday for about 10 minutes. That's all it took us. So what we noticed is that if a force is exerted in the opposite direction of the object's motion, the force can cause the object to slow down, to stop moving, or to move in the opposite direction. And so we also saw when a force is exerted in the same direction as the object's motion, it can cause the object to speed up. All right, so we are going to do kind of this hands-on activity. If you would like to do it at the same time that Mr. Livinggood is doing it, because he has made us a video that we're going to watch. If you would like to eventually do it on your own, then you can do so. It might help you out a little bit more and understand a little bit more. So I'm going to share my screen in a second after we get through some instructions so we can watch a video and do a few things together. All right, so we figured out what causes velocity to change. All right, now we're going to investigate this question. So what causes some velocity changes to be greater than others? What causes some velocity changes to be greater than others? All right, so I want you to respond in the Pear Deck. What are some of your initial ideas about why some changes of velocity are greater than others? What are your initial ideas about why some changes in velocity are greater than others? All right, make sure you're responding in Pear Deck. All right, so somebody said how powerful the force will vary on how the velocity is. So you're saying how strong the force is. All right, so some forces are stronger than others. Greater force. You think the force affects the velocity. Right, the object is pushed harder. Or the shape. That's a good one. I haven't heard that one yet, but that is a good one. The shape of the object. All right, mass and force could be the cause. We aren't going to look at mass today, but we are going to look at the type of force. Right, so I'm seeing a lot of force, people using force. So stronger forces, more powerful forces. Somebody said the shape of the object, and there was somebody that had said mass. All right, good. All right, so to try to answer our new question, we will use the spring launchers to exert different forces on jar lids that are at rest and observe their changes in velocity. All right, so each of these spring launchers has those 3 marks. They show how much force will be exerted. All right, so we can set the launcher to different levels of force. And so if we pull it back to 1, that's going to be a weaker force than if we pulled it back to 2, and a weaker force if we pulled it back to 3. All right, so as we move up, 3 is our strongest force and 1 is our weakest force. All right, if we were doing this in class, this is how we would set it up. So I want you to kind of get an idea about how this would be set up so that we can think about it and answer some of the questions later on. So we would, for step 1, lay a meter stick on the floor or on the table. We would then have 2 jar lids on the floor or table and 1 on each side, so 1 for each partner. And so each partner would have a spring launcher ready to exert a force on one of the jar lids. All right, so the type of forces that would be exerted on these objects or these jar lids, partner A would pull this launcher back to mark 2, and then partner B would pull the launcher back to mark 3. And then after that, make sure you're listening, we would observe which jar lid is the first to reach the opposite end of the meter stick. All right, we would observe which jar lid is the first to reach the opposite end of the meter stick. And then we would record our observations. All right, we would then repeat this 2 more times so we could have 3 trials. So what we are going to do, I'm going to share my screen here in a second. And we are going to go through some variables together. So our independent variable, our dependent variable, and then our control. After that, we're going to watch a video that Mr. Livinggood has put together. He has done the hands-on activity for us if we do not feel like doing the actual activity. And then we're going to answer the Amplify questions on our own after the video. All right, so what I'm going to do, I'm going to share my screen. And I'm going to go into Amplify. So if you want to go ahead and press on that screen on our Pear Deck, it'll take you into Amplify on tab 3. All right, so we are going to look at the variables. So if you want to make sure that you are on this page with me, we're going to be filling part of this out together. And then we're going to watch the video. So make sure you're on this screen, and I'll get started here in a second. All right, so we should be on investigating strong and weak forces. Now, before we start, we need to figure out what our variables are. So what do we need to change in each test? What are we going to change in each test? Okay, what are we trying to figure out? In our directions, what are we changing? Nobody know? Nobody listen to our directions? Right, the force, Kendall. So we are changing how far we pull back that spring launcher, right? So we are changing the force of the spring launcher. Alright, so that is what we're changing in each test, the force of the spring launcher. So one partner would be pulling it back to 2, one partner would be pulling the spring launcher back to the Mark III. Alright, so this is when I told you guys to listen. What are we observing as a result of that change? What are we observing? What would we write down in our table? All right, so Terrence, you're almost there. Natalie said how far the jar lid travels. Kendall said the velocity difference, how far the object will go. You guys are really close. That meter stick is laying down there because we are trying to see which one will get to the end of the meter stick first, right? So we can't really tell how fast it's going, but we can tell which one reaches the end of the meter stick first. All right, we can tell which one reaches the end of the meter stick first. It's not always about how far the object is going to go. Okay, so we will observe which jar lid reaches the end of the meter stick first. All right, so what are some things that will be kept the same in each test? So this is what we call our control. What will be kept the same in each test? And there can be multiple ones of these. There's no correct set answer. There can be multiple controls. Okay, so where the lid starts, I'm just going to put, because I don't have very many, I can't put too many letters in this. So I'm going to say lid starting position. Kendall, yes and no. So the length of how far they go, you could say something about the meter stick. So the meter stick is how we're measuring or seeing what we observe. We're using that meter stick all the time, so that meter stick isn't going to change. How far they go could possibly change, but that's not what we're looking at. All right, so we are always keeping that lid starting position the same. We're keeping that meter stick in the same place. That meter stick does not change. Those dashes on the meter stick don't change it either. All right, so we are going to go into Canvas, and I'm going to go to modules and show you all where this video is that Mr. Living Good has made us. All right, so I'm going to go into today's lesson. If you want to ever go back to the video for this hands-on investigation, then it is right here under today's module. You'll see the objective, closing task, and then the 4 things that we are doing today. And so this video is right here. It's investigating strong and weak forces. All right, so let's watch this quick video.
We're going to be doing the hands-on portion together, unless you want to do it by yourself, that's fine as well. You're going to need your science plunger, and we're actually going to use my cooking board here for my class. Anyway, we're also going to use numbers on the side of the plunger to control about the versions around the different force. There's a four back to one of those numbers you can apply and force. And we're going to
All right, so I'm going to watch that again because it's super quick, but you should be watching which one gets to the end of the meter stick first. Okay, watch which one gets to the end of the meter stick first. All right, that was trial 1. All right, this is trial 2. Watch which one gets to the end of the meter stick first. All right, now this is the 3rd trial. Make sure you're watching which one gets to the end of the meter stick first. All right, so what you guys are going to do, make sure you go back into Amplify. All right, so you should be on this page. If you scroll down a little bit, you're going to see this table. And so this table gives you those 3 trials, and then it asks you which jar lid reached the end of the meter stick first. So either force 2 or force 3. And I'm hoping that when you guys were watching that you noticed that force 3 was the first to reach the end of the meter stick for all 3 trials. All right, force 3 was the first to reach the end of the meter stick for all 3 trials. So what you are going to do on your own, there are 3 questions down there at the bottom. You're going to go and do those 3 questions, and when you get done, you're going to click this hand in button. Okay, so make sure you click hand in after you finish those 3 questions. I'm going to stop sharing my screen and go back to Pear Deck. So once you are done with that and you hand that in, make sure that you come back to our Pear Deck. All right, so if you're in our Pear Deck, there are a few questions here for you about the investigation. So you can go ahead and try to answer those questions. So make sure that you finish the 3 questions on Amplify, you hand that in, and you come back to our Pear Deck and look at these other questions that I have for you about the investigation. They're kind of similar than what you saw. We know that the force 3 traveled faster, obviously, because it got to the end of the meter stick first, but I want you to go ahead and answer these 2 questions on Pear Deck. All right, so we know that force 3 is faster. To get different results to investigate is why we do 3 trials. Okay. So if force 3 had a stronger force, which caused the lid to reach the end, it was important to do multiple trials so you can have the exact answer and be sure. All right, so it is important to do multiple trials because that way we get a repeated answer to make sure that we are correct instead of just doing it once. More evidence in trials. And so we know that if jar 3 was faster, it had a stronger force, or the jar lid that had force 3. So objects may not do the same thing every time. So if you noticed in one of Mr. Livinggood's trials, he accidentally hit one of the jar lids on the meter stick. It didn't mess with the data, but he did accidentally hit a jar lid on the meter stick. So that's one of the reasons it's important to do multiple trials. All right, so we know that the jar lid with force 3 was faster. What can you say about the lid's velocity? You know that if there is a greater force, then there's going to be a greater velocity. And it's important to do multiple trials so that if we mess up on one trial, we can still do more and get a repeated response. All right, so one of the last things that you guys will do is read and annotate the article about friction. All right, you got a few questions, I think, after the reading. Before we get to that, I want to kind of go over the other thing that you need to do and the thing that we did on Friday that a lot of you guys did not show up on Friday. Okay, so before we go back to our homework, which is the reading, there's one other thing that you need to do before class on Thursday, and so that is to complete and submit the exit slip for 1.4 on Canvas. All right, so you've got your homework on Amplify, and you've got your exit slip 1.4 on Canvas. So here's the thing I was talking about. I don't know why I said lesson 1.5. It is lesson 1.3 homework. But if you are not on Zoom on Friday, you need to make sure that you complete the 1.3 homework card sort on Amplify. This is going to end the gradebook. So it is lesson 1.3, not 1.5. I'm sorry about that. You need to make sure that you get that finished. All right. After that, here are some extension links. I think I told you last week that NASA is doing a mission, and so they're collecting some rocks on this asteroid called Bennu. So if you want to watch that, that is right here. There's also a simulation on force and motion. If you would like to look at it, that is here. It's on this website called PhET, and these are actually pretty neat simulations. And then PBS has something on force and motion as well. All right, so for right now, you guys can go ahead and start on this friction article. It is your homework. And then also make sure that you get the exit slip in from 1.4. And then if you did not do the 1.3 homework from Friday, then you need to make sure to do so. Other than that, I don't have anything else for you guys today. If you guys have any questions, just let me know.